last year.
Yes, you're right.
And
Sorry for not mentioning you, Bejo.
yeah, and I am also one of teaching staff of remote sensing and JS in Faculty of Forestry. And it is my great pleasure to serve as the moderator for today's lecture. And I would also like to acknowledge the presence of my colleague, Miss Maria Ulfa, and Prof. Thomas is also her very well because last year is also met Prof. Thomas. I'm sorry, there's some leaking of mic. And we are deeply honored to have with us Professor Thomas from the University of Twente, and he is a distinguished academic whose expertise in spatial sciences and environmental application. Thank you very much, Professor, for taking the time to be here and for your generosity in sharing your knowledge with us. And this moment feel even more special because Professor Thomas has visited our faculty of forestry last year, and we are very happy to welcome him once again. This time in a lecture series. And today's lecture is the first of 3 sessions that Professor Thomas will deliver. And we are excited to begin this academic journey together. And the topic of today's lecture is the role of spatial technology in sustainable forest and environmental management. I think this addresses an issue that is both timely and highly important. As we all know, forests and ecosystem around the world face increasing pressures, and innovative approaches are urgently needed, I think. And spatial technology, including remote sensing and also GIS, plays a crucial role in providing accurate information, guiding policies, and supporting sustainable management practices. And to all the students here, I encourage you not only to listen carefully, but also to participate actively, ask questions, share your ideas, and take advantage of this rare opportunity to engage directly with an international expert. Remember, this is just the beginning of a series of 3 daily first lectures. So let us follow the entire program with enthusiasm. And once again, a very warm welcome to you, Professor Thomas, and thank you for being here with us. And let us now give him our full attention and appreciation. And Prof. Grun, I think we are excited to hear from you, and please feel free to share your screen and start your presentation. I think I must make you as a co-host,
Yes, thank you very much.
Okay.
I'm trying to set up my screen here so that I can make the presentation in full screen mode. Let me see how I do that here.
So you can
to share the screen. Share. Let's have a look. Do you see
yes.
presentation in presentation mode at the moment?
Yeah. Yes, great.
Okay. Fantastic. That's very good. So I can see you guys here. I see my own screen here. So if I look away, that is because I'm looking at my other screen. I hope that is okay.
Okay. Yes, it's okay.
If somebody has a question, that is fine. I think there is also, you can raise your hand in Zoom, isn't it? I normally work with another software, so I have to get a little bit used to Zoom, but I think you can raise your hand, right?
Yeah, I think yes. The student and also the participant can raise their hand.
Yeah, perfect. I will try to speak quietly so that everybody can understand me easily. Please interrupt, and Benjo, if I'm not paying attention, so somebody raises his hand, can you please help me and interrupt and tell me there's a question?
Yes, of course.
Yes, Professor.
Okay, fantastic. Thank you all for being here, and great to meeting again old friends that I met last year. It's really an honor to be invited to give you this story. I gave a lecture last year, indeed, at the Faculty of Forestry, and this was the first lecture I gave there. So for people who attended there, might be a little bit of overlap, But again, you know, a little bit of repetition is also good, right? Because it sticks better in your head. So perhaps it is also still interesting for those people who were there last year. So I was asked by Anita to tell something about the role of spatial technology in sustainable forest and environmental management. And I will do that with these slides. And what I have prepared for you is this. So I will tell you a little bit about my university, because I think for bachelor students, this could also be interesting, right? To think about, okay, do I want to continue studying perhaps abroad? I know that students from Indonesia are always very active also in looking for options, but I know there's also master students here. And of course, if you're already following a master, this might not be so interesting. But still, I would like to tell you, we also have a PhD program, and I know LPDP also has scholarships on this. We have students that do PhD studies at our university. So we're always very happy to collaborate with people from Indonesia. Then I will say something about sustainable management and forestry. I assume most students are from the forestry faculty. Is that correct? Or is
Yeah.
it more faculties?
Yes.
Yeah, all of them
Yeah.
All
from
of
forestry faculty.
Okay. Yeah.
Okay.
Yeah. So I will talk a little bit about forestry and environment, and then I will go towards the remote sensing and the spatial data, and something that we work a lot on at our faculty. So let's start with the University of Twente. This is actually, we have a little bit like you have in America, Hollywood letters. We have our University of Twente letters at the entrance of the campus. We like to show off with that because it makes you feel a little bit at home when you come there. It is a very nice sight to see. And if you come at our campus, here you see the letters from the air. You see here in the back a very long building. There's some trees behind it. Let me see. Can I have a pointer here? There should be something like a pointer, right? Over here, I can draw in the point. Here, there you see, right? This here, that is a very long
Yes.
building. That is where we are situated. So really at the entrance of the university. And there is situated the Faculty of Geoinformation Science and Earth Observation. So this is a faculty which is completely focused on working with spatial data, coming from satellites, coming from drones, coming from any kind of information that you can collect, as long as it is spatial and as long as it has an application to different domains. That could be disaster resilience, that could be food security, that could be forestry, that could be urban planning. All these topics are covered within this center or this faculty of the University of Twente. So the name of the institute is called Faculty of Geoinformation Science and Earth Observation. And we have a very international audience. So a lot of our students come from other places in the world than the Netherlands. So we have Indonesian students, we have students from the continent Africa, we've got students from Latin America. It's really all over the place. And of course also from the Netherlands. So that is a really nice international experience. I need to get rid of my drawing. Can I clean that here? I think like this. How do I do that? Wait. So now the drawing is gone again. Yes. So we have a really nice new building. We moved recently to a new building. And here you see a little picture inside because we have big gardens inside our building. So it's quite a nice building and atmosphere. And what you see here on the right, let me see, is there like a pointer here? I think this is... Can you see my mouse moving over the screen?
Yeah.
Okay, great. So what we have here is at the bottom floor, you can see here in the garden, that's where the offices are. So that's where all the teachers are and where the lab facilities are. But here at the top, we've got all the lecture halls. So here on the right, you see some lecture halls, but also working places for the students. So they can actually do, when you have to do your own assignments or whatever, we've got a lot of very nice light space where students can work. Let me see, what was I going to say here? What we really focus on in our university is that students learn how to work on societal issues. And so as a global society, we are dealing with climate change, we're dealing with food insecurity, we are dealing with biodiversity loss, all very important topics. And that is not something one person can solve by themselves. So as society, we have to do something. And we think that spatial data can be very important in working on this. But it is never only spatial data, right? So it is, of course, spatial data together with understanding how systems work. And I think forestry students are a perfect example of this, because forests are a very important system in the world. So understanding how they work and how you use spatial data for that is very important. And on top of that, the last word that we say here, socio-economic knowledge, right? So there's never something happening in isolation. All the things that we do as humans are related to social processes, right? Everybody wants to have a house. Everybody wants to have a mobile phone. Everybody wants to have food. And everybody needs to be able to pay for that. So also the economic processes, right? If you do something, what do you get in return for it? And this is, of course, very important, for example, for a person like me, who's very interested in biodiversity conservation. But biodiversity conservation hardly ever earns a lot of money. So if you say this is important, then you have to come with alternatives for people who want to develop something else. So we always think it's these three things: spatial data, technical knowledge, and socioeconomic knowledge that you have to combine. We have some QR codes here, but I will share the slides so you can look at it later. Because you can scan these slides, you will find out on our website about open days and different programs that we offer. So I think I have said enough about our university, but if there's any interest among the Master of Science students or the Bachelor of Science students, then I would say check out these QR codes afterwards. Okay, so that is all about University of Twente. Let's move on. Let's move towards sustainable management. And then my first question is, what is actually sustainability? And I thought, you know what, let's first ask this question to the students. Is there a student who has an idea how they would want to describe sustainability? And don't be shy, you don't have to give the perfect answer, because I think we can make a good answer together, right? So a wrong answer is also fine, because it starts a discussion and it stimulates you to think.
Yeah, Sarah, please.
Prof. Thomas, I think I would like to answer about these questions.
Yes.
Well, I'm still remember about these questions when the last time when you asked the same question to us, what is sustainability? And I still remember about my answer. Sustainable means about something that can last for a long time without causing harm and without causing harm to the environment or future generation. So it means it always continue to be application and we can use it for the long time, especially right now and in the future. That's what
very nice. Thanks, Osara.
Okay.
Very nice definition. So indeed, sustainability has to do not with the now, but also with the future, right? So how do we make sure that we make choices now that are also going to last for the future generations to come, right? So if we look at this, this is a very generic description, a social goal for people to coexist on Earth over a long period of time. So it's really about the long term. And you could imagine, for example, if we just have a desert where nothing lives and nothing happens, it's very sustainable, it doesn't change. But of course, this is not about coexisting then, right? And that is exactly a very important part as well. It has to do with that humans, but also other organisms, plants, animals, can sustain themselves also in the far future. And you see here, this is what we call a Venn diagram, right? So those circles, this has three domains that it is covering. Of course, it is the social domain, right? It is the people that need something. At the same time, we have the environment. So we want to make use of the environment. Think of agriculture or forestry, where we actually extract something out of nature. And of course, if we want to do that sustainable, we want to make sure that people that come after us can also still extract this without destroying nature. And the third component there is economy, right? If you want to extract something from nature, but it only, yields money the first year, but after that you only run a loss, then it's also not sustainable, right? So there's also economic sustainability that you need to take into account. And it is really the integration of these three that makes something long-term sustainable. Now, of course, I'm not really telling anything new here, because sustainability has been on the minds of people for a long time and is also internationally recognized. So the United Nations has developed what they call the Sustainable Development Goals. And these are 17 different goals that we as a global community, so all the countries in the world, or I should say almost all the countries in the world, because not every country is signed up to the United Nations, but most countries are. We said we need to do something against these sustainability goals. And you can see in these sustainability goals, and also a little bit how they are ordered, that there are certain things that we prioritize. And so you see, number one, no poverty, right? So we really put humans first, right? We are really concerned that, we need to make sure that people have a good life, and that means that there's no poverty. And also the second one, right? Zero hunger. And the third one, good health and well-being. So these are really human focused, but also important sustainability pillars, because if people are no longer poor, they do have sufficient food and their health is being taken care of, their necessity to actually destroy nature to survive, for example, becomes less, right? So we also need to think very clearly, how can we organize and support society so that we can actually do sustainability issues. And you see later on, we also have clear water and sanitation. Topics I often focus on are, of course, climate action. And you see it's a little bit late in the list, but it is actually a very important long-term goal, right? Because if we don't do this, then also those short-term goals actually come under pressure. Life below water and life on land, very important thing. So this is also where forestry, agriculture, biodiversity conservation come into play. Now, the fact that as a global community we talk about sustainable development goals is actually quite special, because it wasn't always like that. Very long, people were just focusing on economic growth, right? It was a little bit short-sighted, we realize now, but at the days, especially after the Second World War, people said, okay, we have to build our nations again, we need to earn money, we need to work. So the focus was really on economic growth. But this started to turn when there was a report published called The Limits to Growth. And there was a group of people, they collected in Rome, and they started calculating in very simple models how much resources do we have globally available. So they started to realize, we cannot continue pumping up oil, we cannot continue chopping down forests without at some point depleting all these resources, right? There is oil in the ground, but at some point there's no oil anymore. Then what do we do for heating? We can chop down forests, but at some point there's no forest left anymore. So then we cannot continue with it. So they started thinking about what are the total amount of resources. And you see in this figure here, they started modeling it with very simplistic models. So they said, okay, what are the total amount of resources in the earth? This is forest, this is biomass, this is oil. And they said, okay, what is the total population? That's the black line over here. And we know that currently the global population is growing. And it's still growing, right? So since the 1970s, it has been growing very steadily, or actually quite fast. But it is very slowly tapering off. So the population globally is getting slower in its growth. It's still increasing, but not as fast anymore as it used to be increasing. But of course, all these people that are born, they want something, right? They need resources. So the use of resources is really dropping. And as a result of that, the food per capita, so how much material or how much resources we have available per individual person, was initially increasing, but at some point it will decrease again. And this is already something that is in economics studied called degrowth, right? Because we cannot always continue growing, and everybody having more and more and more. So we need to think, how can we do this better, right? How can we use less material or less resources and still have a good quality of life? And this is really the big challenge of current and future generations, because quite frankly, and I can say that from my country, the Netherlands, where I live in, a lot of people have a very good life. They have everything they want. But if they want to continue that, then really something has to change, because the consumerism, as we call this, that people have, buying a lot of stuff and then throwing it away again, is something that is not very sustainable. So this really has to change, because, and that's the gray line here, with all this stuff that we use and then throw away, we get a lot of pollution, and this has very negative effects on the environment. So this publication really made people aware, wait a minute, something has to change. We cannot always continue growing relate to management, right? Because what we see here is very clearly a forested area that has been deforested, right? So you might wonder, is this then unsustainable? Because I see a huge area being deforested. At the same time, perhaps I need this area, right? Because I have people that need food and they need to be fed. So yeah, is this sustainable or unsustainable? And this is all a matter of proportions, right? So how much food do we need to produce? And at the cost of how much, for example, pristine forests that we can chop down for them. So we really have to quantify this in numbers. And this is, of course, one of the things where spatial information like satellite images can come into play to help us give this a more clear answer. So questions to address are, for example, how much area do we have with forests? And we have a lot of these answers already there. There's a lot of studies being done on this, but this is also constantly changing because how do you define a forest, etc. Then if you know how much forest there is, another very important thing is, how is this forest doing at the moment? So what we see, for example, is that a lot of forest is being chopped down, and then we put, for example, oil palm in there. If we look from the sky or from the space, it still looks like a forest, right? But it's really a different type of forest. The same happens in Europe, where we have a lot of forest that is used for production. So it is not very rich in species. It is very simple forest, right? It's just one species in there. It's very useful for production, but it's not so useful for biodiversity, and perhaps also very sensitive to, for example, droughts or insect outbreaks. So the state of the forest is a very important thing to consider. Also, when you think about climate change, for example, in the Netherlands or in Europe, we experience more and more droughts in summer. So some tree species are very sensitive and they do not survive under drought conditions. I know that in Indonesia, I think on the island of Java 2 years ago, there was also quite a heavy drought. It's also in tropical areas, droughts are an increasing problem. And then, of course, the question is, how does this affect the state of the forest, and can it still provide all the services that we want to get from it? Sometimes, very simple, we want to know how many trees are there in the forest, right? How many trees are there? What type of trees? So also, for example, what quality of wood do we have there? So there's a lot of questions that we need to consider, and where we sometimes can use satellite images or drone images to get answers to these questions. Oh yeah, and of course, when we talk about biodiversity, we also have, for example, questions about how many species are there in a forest. And of course, we can ask that question for the tree species. But likewise, we might want to know what kind of animal species are living there, or what kind of insect species are there. So there's a lot of these kind of questions that we're interested in and that we need to consider when we talk about sustainability. Wait a minute, why is there nothing happening now? My laptop is freezing a bit. Let me see. Why are you not switching? Oh, somebody raised a hand, I see. Yes, please. Reinhard, I think, was the name.
I think you can show the right hand.
Was that by accident? That's of course also possible.
Yeah. Mhm.
Okay, no problem. If there is a question, I think it's very good, then please don't be afraid to raise your hand. Here we go. So we talked a bit about sustainable management, and then of course the question also is, how does that link to forestry? And for that, I also have a question, and that is, what is actually forestry? And again, I think it's nice if a student can give a suggestion. You guys are from the Faculty of Forestry, right? So it would be very hutanan, right? Hutanan is the Bahasa word for forestry.
Hutan.
Hutan, sorry, yes, yes.
Ya, kehutanan.
Forestry kehutanan. Sorry,
Mm-mm.
sorry.
Hutanan, yes, okay. So hutan is the forest, right? And hutanan is the forestry. Yes.
Ini
So I was wondering if another student can tell us something about how they define forestry, and perhaps a different student than last time, right? So everybody gets a chance, or most people.
nggak
Okay,
apa-apa
I think
campur-campur pakai bahasa Indonesia kalau nggak ngerti.
yeah,
Ya,
I think you can also ask in bahasa, and me or Bu Ulfah will translate to Prof. Grun.
ada
Yes.
Sarah juga.
Oh, Sarah
Ayo,
udah.
silakan
Cinta,
siapa yang
Cinta,
mau.
kau nanya, Cin? Apa itu forestry, Cin?
tahu lah kehutanan itu apa gitu.
Please, Cinta, you can answer the
Mana
question, please.
Cinta?
You can unmute.
Oh ini udah Cinta nih. Ya silakan.
Please, Cin. What is forestry?
Better in English.
Yes. Don't be shy, students. Come on.
Masih mute. Cinta, you still mute.
Okay.
Oke.
Jadi kalau pakai bahasa Indonesia aja, Pak.
Inggris
English
lah.
lah.
In English lah.
In English lah.
So Dr. Thomas will understand.
I will try to listen very carefully. Don't be
Yeah.
shy. It's okay, Sinta.
Jadi forestry itu is the branch of science with the overall administrative, yang legal, ekonomi, kemudian and social aspect, as well as scientific and technical topics yang relate to forest.
Okay, yeah, wow. That's a very nice and very extensive definition. So you take into account the social dimension, the economic dimension, right? And the management dimension of forests. Yes, that's very nice. Thank you very much, Sinta. I think I really like your definition. So I had this as a definition. So forestry is the science, that's what you also mentioned, and craft of creating, managing, planting, using, conserving, and repairing forests for, and then it says associated resources, right? And of course, this involves also society, right? Because the management is never done only by, one forester. There's always people living near the forest or in the forest. So the social aspect is very important. And what's also here, using is often because we want to extract something from the forest, but also, of course, the conservation, right? So we want to keep the forest sometimes for very important reasons. What is also perhaps interesting here is that because this is an international definition, it says forests, and I made that word bold, but also woodlands, right? Because in some parts of the world, forests are not the dense tropical forests like you have on Sumatra. But I think, for example, also in East Java, you've got more the savanna ecosystems where there's much less trees, but it's still kind of a forest, right? It's semi-natural area with quite some trees in there. And also these are basically part of forestry. Myself, I did quite some field work in South Africa. There we have savannas as well. And also there, this would be part of forestry, basically. Okay. And then, of course, what are the associated resources of a forest? And I was just curious if perhaps Cinta, you're there anyway. You have any, what are the resources that we want to get from the forest? What would you think of?
Apa, Cin?
Cinta.
Apa, Cin, yang tadi?
Explain it. Yeah. Explain from your perspective.
Associated resources.
What do we want to get from the forest?
Kira-kira hutan menghasilkan apa aja?
Non-timber product, Prof.
Ya, Manuel.
Yeah, Manuel, you can answer.
Yeah.
I think it's one of non-timber product.
Non-timber forest product.
Yep. Yeah.
Sorry, I didn't hear that very well once again.
I'm sorry, Prof. I think it's associated with non-timber product.
Non-timber products, yes. Yeah, that's one very nice example. So, quite frankly, if I think about associated resources, the first thing I think of is wood, right? That is kind of the topical one. But I agree with Manuel. Also, the non-timber forest products, so NTFPs is what we often call them, are very important. And this could be a lot of different things. Could be, for example, wildlife that people hunt from forests, or leaves that are used for certain applications, or fruits, or mushrooms. And there can be many different types of resources that you can get from a forest that are not wood, but that are also very relevant for the livelihoods of people who live in the forest or near the forest, etc. Another resource that a lot of forests hold, and this is something you cannot very easily sell, but that is actually very important, is biodiversity. And I think actually you have a very good example in North Sumatra, because you have forests and there live orangutans, right? And these are a very special animal that are unique in the world and that need a lot of protection. Although this is also something that to some extent you can earn some money with, right? Because if tourists from across the world want to see this iconic animal and go there, and they pay entrance fee, for example, they are actually also a resource that has an economic value. And very important, ecosystem services. And ecosystem services are normally services that are not extractable. So this is not the wood, this is not the NTFPs, because this requires you to take something out of the forest. But ecosystem services is, for example, that the forest is, when it rains, the water stays in the forest and it is not running off downstream. So you actually avoid flooding because of forests, right? This is, for example, an ecosystem service. You could even say that the forest is holding all the biodiversity, and this is an ecosystem service. Or, for example, what we know is that in forests there are sometimes certain animal species residing that hunt on pest species in the crop fields. So, for example, bird species that eat all the insects that eat your crops, then the ecosystem service is that it is hosting all those pest species that are normally feeding on your crops in your agricultural field. So these are examples of ecosystem services, and actually very important, because when you manage the forest, then you should think of all these different aspects, not only about harvesting wood for, I don't know, the pulp factory or for selling wood for timber, but also all the other services that a forest can deliver. So I also put some dots here, right? This is just one of the things we can think of, but there's many more things that forests deliver. And every country and every place has often unique services. Something I, for example, did not mention yet here is cultural services.
Yes.
It is a very known example in Ethiopia, in northeastern Africa. They have what they call church forests. So those are forests that are sacred, and it doesn't matter what you need. You can never go in those forests and chop anything down because they are reserved. And there might also be places like this in Indonesia that are forests that are for cultural purposes important. And then, of course, that is also service that they offer, their cultural inheritance, and therefore you should not touch them. I saw a hand raised and then it dropped again. Was there a question or was that accident?
I think it's just accident, sir.
I think just like I say.
S first.
Okay, no problem. But if there is a question, then no problem as well. Huh? Okay, good. So let's move on. My computer is doing very slow again. I don't know why. Oh, yeah. So what is important to realize when we talk about forestry, and I always make a little bit of a joke to my students when I talk about forestry. I always tell them foresters are a little bit lazy farmers, right? Because a forest grows very slow. So a farm, you plant something and within 1 year you can harvest. But with forests, it goes, well, depending a bit on where you are in the earth, it goes very fast or very slow, mainly very slow, right? So I know that in Sumatra, if I look at the production forest, I think they can harvest every 5 to 6 years, which is extremely fast. But in a lot of other places, for example, in my country, a forest easily needs 20 to 30 years before it is mature. So what you get is this very slow kind of development of the forest over time. And then if we do something, for example, we harvest it, it will drop, and then very slowly it will recover. So often you have these kind of dynamics happening in a forest at a relatively slow pace. And when you start managing the forest, you have to take this into account. You cannot harvest every year. You cannot do so. You need to somehow spread out your activity over time in such a way that if you harvest somewhere, there's enough place left where a forest can recover after the kind of, bottom and peak type amounts of biomass, but there's also this long-term average. And this is, for example, important when we talk about how much carbon is in the forest. And we're interested in that from the viewpoint of climate change, because we know that if we store carbon in the forest, it is not in the atmosphere, and this would actually be a way to avoid too much global warming. But that only works if we do not harvest too often. And of course, this is not always going right. So I have an example here. This is from Brazil, where a lot of harvesting is happening. Wait a minute, there we go. And this is a time lapse of, look at the video. So what we are looking at here is satellite images from multiple years in a row. And it is showing how areas that were completely 100% forest are slowly being transformed. And it has been cut, it's not left alone to recover. People start using it for agriculture. And you really see that there are still a few isolated patches left. But it starts with a few roads that are being cut into the forest. Then people expand and they expand further, and slowly this is changing. Now, clearly, we can use satellite images to look at this and say, okay, how fast is this going, or how slow is this going, and how much forest are we losing, or is the forest coming back? So the diagram I was showing in the previous slide, that's going up and down, that might, of course, also happen. So satellite imagery can help us to look at, hey, what is happening? What is the extent of what is happening? And how serious is this? Okay, so we talked about forestry, we talked about sustainable management, and then we still have this last term that was also in the title, environment. And the question is, of course, also, what is that environment? And I have a little bit of a silly icon here, of a recycling symbol. But perhaps there's yet another student who would like to give me a first indication. What do you think is an environment? What do we mean by that?
Ayo, siapa lagi kira-kira kalau mendengar kata environment, kira-kira bakal apa yang terlintas? Pengertiannya sudah sampai di mana? Siapa selain Oisara dan Cinta? Kayaknya dipanggil aja Pak Bejo.
Ada Miduk tuh.
Excuse me, Prof.
Oh,
I want to
oh, ada Midu ya.
answer your question. So I think environment is everything that surrender and affect living organism, including humans. It consists of both natural components such as water, soil, plants, and animal and climate, and human-made component like building, roads, and technology. So the environment provides the research and condition necessary for life, and is also influence health behavior and development. In short, the environment is total surrounding in which living things exist, interact, and depend in each other. Maybe that's my answer. Thank you, Prof.
Yeah, very extensive, but very good answer, I think. So you're covering a lot of things. I had a little bit of a simpler definition, but I really like your definition. And you very clearly said it is everything that is the environment or the surrounding of an organism, right? And that could be plant or an animal, but it could also be humans, right? So we are also influenced by the environment. And everything that influences it. So that is the climate, that is the soil, that is the human modifications. So for example, if we make something, buildings in an urban environment, that's totally different than when we are in a natural environment. So I think you really gave very many concrete suggestions on how to define the word conditions, right? Because there's many different conditions that we have to think of. That was actually my next slide as well. So what are the important environmental variables? And well, you mentioned climate and weather. And that's of course clearly something that is determining how organisms can survive somewhere. So if we look in Sumatra, what is growing there, and if you would come to the Netherlands and you see what is growing there, really different plant species because the temperature is much lower here. I think there's much less water, so it's raining more frequently in Sumatra. The soils are different, so there's a lot of different things, but that is a very important driver. Topography. And so do we have mountains, yes or no? Because that determines, for example, if you are on a slope, yes or no, if an area is rocky or has deep soils. Whether you receive a lot of sunshine, and close to the equator this is less relevant, but if you move to the area where I am in, if you have a slope facing south, you get much more sunshine than when you're on the slope facing north. So it has a huge impact on the temperature that you experience. Geology, so what is the underlying ground? Is this, for example, very nutrient rich parent material or nutrient poor parent material? That makes a huge influence on what kind of plants can grow there, and that results in animals that can live with it. And of course, the land cover. Is it covered by forests or grassland or something in between? And you also mentioned, Miduk, the human activities, right? So what are humans doing there? This is a very important driver and becoming more and more important. Humans are really exerting a lot of influence on the Earth's surface because of all the things that we need. And I just showed you this video of the deforestation happening in Brazil. And of course, this is all human activities. And it's also changing land use from forestry into more open grazing areas for cattle. So it is changing also the land cover. Okay, so we've talked about environment, right? What is it? Now, ultimately, that's what we try to do in our faculty, but a lot of people work on this. We would like to use information that is spatial, and one of those sources of information is remote sensing. So information that comes, for example, from satellites. So I wanted to tell you a little bit about remote sensing. And to start with that, I want to explain the different systems that we have. And well, I'm drawing here a satellite. I hope you understand this is a satellite. This is my poor drawing of it. But we have different types of satellites. And the first one that we have is what we call passive satellite systems. And passive satellite systems, they basically make use of the fact that the sun is radiating light to the Earth. The Earth absorbs this light and then actually reflects it back, but not everything. So part of the light is being absorbed. And for example, when you have a green surface, then most of the light is absorbed except for the green light that is being reflected, right? So we get, I call it yellow, but basically this is all different colors are in the sunlight, and only the green light is being reflected back by vegetation. This is very important for reflectors of visible light, as we call this. And it goes actually, so our human eyes can see visible light. There are actually more wavelengths, not everything we can see with our bare eyes. But satellite sensors are also sensitive to other frequencies that we cannot see, and often we call these near infrared. Now you can only work with these satellites if you operate what we call sun synchronous, right? So the satellite has to be on the same side of the Earth as the sun, because otherwise there's no reflectance, right? If the satellite would be behind the Earth, it would not catch any reflectance. We do have satellites actually that go also asynchronous, so that are out of sync with the sun, because at night we have, of course, lights on, and sometimes it's interesting to look at, okay, where are city lights burning, etc. So we look at that as well. But most satellites operate sun synchronous, so they are at the same place when the sun is shining on that part of the Earth. But we also have satellites that look at what we call midwave or thermal infrared. You might know that objects that are having a temperature, so that are not at the absolute minimum temperature of minus 273 degrees Celsius, they automatically radiate longer waves. So you can see here in the drawing also, I made the waves a little bit longer. Long wave radiation. There are satellites that can measure this. We call them thermal infrared satellites. And those don't have to be sun synchronous. So they could also be at the back of the Earth, so when the sun is on the other side, and they can measure how much energy is coming from the Earth's surface. This gives information, for example, on the temperature of the Earth. So how hot is the surface of the Earth? But it also says something, for example, about the condition of plants. Plants that are very healthy, trees that are very healthy, that are able to evaporate, for example, water, they are much cooler than plants that are stressed because they don't have enough water. So then the temperature will rise, and we can measure that with these type of satellites. These are both passive systems. We also have active systems. Active systems are active because they actually send a signal to the Earth, and then that signal is being sent back to the satellite. And the typical satellites that we have there are called SAR, synthetic aperture radar. So these are radar satellites. They send a signal and the signal bounces back to the satellite. Why is this interesting? Well, one of the things you can do with radar satellites is you can actually measure height differences. So radar satellites are very useful, for example, to measure how high a forest is. And there's different wavelengths that you can look at, and some radar satellites penetrate through the canopy so they can measure the ground. Other satellites only measure the top of the canopy, so they measure how high it is. So depending on the radiation frequency, you can measure different things. I also mentioned here LiDAR. Now, LiDAR is hardly not available on satellites, but it is available on a lot of airplanes. I will show you some examples. This is light emission and detection and ranging. So this is where you can also measure distance by sending out a light pulse that hits an object and then it bounces back. And by the time it takes the light pulse to travel up and down, you can calculate how far it is. So you can make a point cloud out of that and you can measure all kinds of things. I have some examples later on. There is actually an experimental satellite also with LiDAR, but you can imagine that, long wave radiation from a radar satellite that can travel really long distances, but light is much shorter wavelength, and actually the speed is equally fast, but it's much more sensitive to disturbance. So we have some satellites that do this, but not very many. Okay. Before we dive in satellites, there's a few things that are important, and one of those things is the different dimensions that we have to consider when we talk about satellites. First of all, we have what we call the spatial dimension. So how big is an area that a satellite or an airplane or a drone can cover? And often what we look at is, for example, the flight path. So when it is flying, how wide is the line that it can scan? And this is the same for satellites or for airplanes or for drones. You have a certain viewing angle, and depending on how high you are flying and how wide the angle is, you have a maximum width on the ground surface that you can cover. So that is the extent. And the other part is the resolution. And the resolution has to do with if every image, whether this is from your telephone or from a digital camera or from a satellite, it is built up out of pixels, so small points next to each other. And then the question is, how big is that point on the surface of the Earth? If this is really small, we talk about a high resolution. If it is really big, we talk about a coarse resolution. And you can imagine that if we have very coarse resolution, it is very easy to very quickly scan the entire Earth. So we have some satellites that make a picture of the entire Earth almost every 15 minutes. But those pixels are huge. So one point in those images is 100 by 100 kilometers. There's also satellites that are very high resolution. So they can zoom into the Earth and every pixel is 1 by 1 meter. But you can imagine that if they are very high resolution, then the extent is really small. Right? You cannot scan the entire Earth at 1 by 1 meter resolution for the entire Earth. That's way too much. That's too much data. So there's always a trade-off between the extent and the resolution when it comes to the spatial dimension. Then we have the dimension of time. So satellites are sometimes crossing the Earth, so they're circling around the Earth. There's also some satellites that are constantly at the same point around the Earth. We call those geostationary satellites. And they make an image every 10 minutes, or every day, or every 10 days, or every month. And this is the temporal resolution. So we can have very frequent observations or very infrequent observations. And you can imagine that the higher the resolution, the more difficult it is to have a very high temporal resolution. For time, you also have the extent. And this has to do with how long have these satellites been monitoring already. So there are a few satellite programs, Landsat is very famous for that, that have been already collecting data since 1970. So those have a really long extent. There's also satellites that have just recently been launched. recently there was a new satellite launched called Biomass by the European Commission, and it is going to detect changes in biomass, but that one is only 1 year in orbit. Now, the last dimension that we have to think about is the spectral dimension. I already said some about wavelengths, right? So we have visible light, we have thermal light, etc. If we look at the entire spectrum of light, then there's a very small part that is visible. That is what we can see with our eyes. But if you go to longer wavelengths, we get into infrared, microwave radiation, radio waves, or we can go to ultraviolet, X-ray, gamma ray, the more shorter wavelengths. Different sensors can measure different frequencies of electromagnetic radiation. And some satellites can just see one band, so they only see light, for example, black and white. And other satellites can see many different sections, so they actually scan different portions of the electromagnetic spectrum. So we have satellites that are on band, so they just measure, for example, these are the bands from the Landsat satellite, so that has 3 sensors that are sensitive to red, green, and blue. One in the near infrared, one in the mid infrared, and another one in the mid infrared. There's also satellites that can actually measure every little single frequency by itself. We call this hyperspectral satellites. So also there's the difference between the extent, how big is the range of electromagnetic radiation that they can measure, and how many different colors can they actually see. And we call this the resolution. Okay. I was talking about satellites a lot all the time, but it's not only satellites that we can use. Of course, satellites are an important tool, but also aircrafts are very relevant because aircrafts can also collect data. And the nice thing about aircrafts is it's often easier to plan. And these days, of course, drones, or we often talk about unmanned aerial or unpersonneled aerial vehicles. So things where not a person is on board that are being remotely controlled. And we have the multicopters, so this is a quadcopter or an octocopter, the ones with the rotors, look a little bit like helicopter. And we have the fixed wing drones. And both of them are very useful for remote sensing, where the multicopter versions are very easy because they can hover over the same place. So they're much easier to operate, and a lot of people that have a drone pilot license are allowed to fly with these. But the fixed wing ones are also really nice because they can cover much larger areas with less fuel. So they're actually more efficient if you want to cover big areas. Then those fixed wing drones are actually much smarter. Apologies. And then lastly, we have ground-based observations. And as an example here, I show a LiDAR instrument. I will say something about that later. But a LiDAR instrument actually is an active system, so it sends out a pulse of light that bounces back and it measures distances. But you can put that, for example, in the forest, and it will measure all the different tree trunks and how big they are and how far they are from each other, etc. And this is also a way of remote sensing. So just what I said, we have LiDAR. How does it work? It normally works with a GPS, or a global positioning system. And what it does, it actually sends out a pulse, could be on the ground or it could be on an airplane. It sends out a pulse. That pulse is bouncing back. And what it measures is the time between the time that the pulse left the airplane and it bounces back. And what it can do then, it can build out a point cloud. So for every location here in the field, it knows, okay, here's a point, here's a point, here's a point, etc. So what you get is a point cloud. And that is illustrated here. So all these little dots are points. Yeah, so this is where the laser signal came. It hit the tree, it bounces back. There's actually a second return because not all the light is bounced back. So the second, so you've got a third, etc. return until it also hits the ground. So what you get from LiDAR remote sensing, either on the ground or from the air, is all the red points that you see here. So the green is the illustration of the tree. You don't see the tree with a LiDAR, but you see all the red points. And from that, you can often extract information. For example, what is the peak height of this tree? What is the ground level? And sometimes they can even extract, for example, how thick is the trunk of the tree, or how many leaves are there on the tree, these kind of things. So LiDAR remote sensing is very useful for forestry inventories. And we have what we call discrete return. So we just look at the points. Where are the points? So from which points do I get a return? And we have what we call full waveform LiDAR, because the first return might actually be a very strong reflectance, while the second one gives a much lower reflectance. So you have something that gives a very strong return, much less strong return, etc. And this is also information that says something about the surface properties of this leaf, of the soil, of this branch. So when people work with LiDAR, they have sometimes discrete return that gives a lot of interesting information about forests, and sometimes full waveform return. And that also says something about properties. For example, how much water is there in the leaves, or what type of soil is there under the forest. Now, why is this interesting for people who want to manage forests? First of all, it can give us information on how high is the forest. And this is already very interesting information. It says something about how old the forest is, how much biomass is in there. It can also say something about what does the landscape under the forest look like. And do we have very steep terrain, or is it rocky, or is it very shallow? So we can also get information from subcanopy topography. And we can get information on how are the leaves distributed through the tree. And this is also very interesting, especially when you think about biodiversity. That often forests with very complex canopies, where there's gaps in it, and you've got multiple layers of leaves over certain meters, then it's often much better habitat for animals like orangutan than forests that only have leaves at the top and then they're just bare trunks. So the distribution of leaves over the canopy is also very relevant information. And often from that we can extract other information. For example, the basal area, or the stem diameter, or a canopy volume, all these different things. I hope the terms I'm using here, so leaf area index, canopy density, canopy volume, that these are known. Everybody knows these terms? Or are there words here that somebody says, I don't know what this is? It's very quiet. I hope everybody knows what this is, and otherwise, please do reach out later, right, to make sure that you do not miss out here. Okay, so this is what we can get from LiDAR. Here, I show you an example of a terrestrial LiDAR, right? So this is, again, this instrument that I was showing. If you would put that in a forest, then actually what it makes is a three-dimensional representation of the entire forest. So you can see all the stems here. Here's some detectors here, so you can calibrate the instrument, but you can see all the individual stems, and you can start counting stems. How many stems are there in the forest? How thick are those stems? So you can get stem count, DBH, the shape. Are they nice and straight, which is often for foresters very important? Or are they very crooked, which is often not so preferred by people that make harvests from forests? So you can get a lot of interesting information from terrestrial LiDAR systems as well. And often there's a way to represent this, right? So this is the same tree in two different ways illustrated. We don't have the real tree at the moment, only those point observations that come from the LiDAR system. But you can look at the top and say, here are really the high points and here are the lower points, and you can see what is the area that the crown takes into place. But you can also look in 3D and you can kind of see, okay, what is the shape of this tree canopy? So it gives a lot of interesting information. Another source of information is, of course, just regular red, green, and blue, or RGB images. And a lot of drones can collect this, right? So those octocopters or those fixed drones, we can fly them over an area, and you get a picture like this. And well, you don't need any fancy equipment. Just with your telephone, you can make this. If you would have a hot air balloon or a kite and you put a camera under it, you can make a picture like this. But one very important development that has happened in the past is that what we can do is we can make actually three-dimensional pictures from regular images. And this is called structure from motion. So if I fly over an area and I take a picture and I take another picture later on, but there's some overlap between those pictures, I can actually make a three-dimensional picture out of this, because from different angles I'm looking at the same object. Now, this is a phenomenon that we know already very long exists, because, well, this is like an old 3D scanner from 1800 something, where people already had, if you take a photograph from two slightly different angles, and put them, and one eye sees one photo and the other eye sees the other photo, that is exactly what this instrument does. Then you already see a 3D image. If you do that in a software that can process it, so you would have these images from multiple angles from the air, you can combine them and you can actually get information on how high are those trees. So you can actually extract already three-dimensional information on tree canopies by having multiple simple images just from your camera and process that. And one of the softwares that exists is called Pix4D. This is very popular under people who work with drone imagery. They can put all the images in that software, and then that software will make a three-dimensional image of the forest that you were flying in. Okay, so I talked a lot about remote sensing techniques. I talked a little bit about satellites, but I would like to dive a little bit deeper because, well, we have a lot of different satellites out there. And I think it's nice also to know a little bit, okay, what are all these different characteristics of satellites? And I have here a table. You will get the slides in a minute, where I mention a lot of satellites that exist. And quite a lot of them are also publicly available. So everybody can work with them because they are paid for by governments, by the United States, by the European Union, by the Japanese government. And those images can be downloaded for free. So the most often used satellites for forestry are Landsat. I already mentioned it. This is the longest running program in the world when it comes to Earth observing satellites. And the latest version is version 8 and 9. And they have a ground resolution of 30 meters. So that means that every pixel on the ground is 30 by 30 meters. And every 8 days an overpass is coming, but they often combine those. So ultimately what you can download is every 16 days. So every 16 days you have an image. This is really nice, and what it says here also, it has already more than 40 years of data for Landsat. So it's really a very rich source of information, especially when you want to look at, for example, deforestation. So the animation I was showing you from Brazil, that was based on Landsat imagery. Then we have Sentinel. Sentinel is from the European Space Agency, and it has a higher resolution in the visible light, 10 meters, and a little bit lower, but still higher than Landsat in the shortwave infrared. And it has a higher revisit. And so there's actually two satellites that are following each other, Landsat 2A and Landsat 2B. But together they have so every 5 days you have an image with a higher resolution. So it is really high resolution, multispectral, gives us a lot of good information. The only downside is it only started in 2015. So the time series from Sentinel satellites is only 10 years so far, which is of course nice, but not yet as extensive as the long time series that Landsat offered. Okay, I'm not going to run through all these satellites here. I think that would be a little bit too much. What I did want to mention though is the Sentinel-1. And why is Sentinel-1 interesting? Because this is actually, well, it says here SAR, so that is a synthetic aperture radar. That is one of those active satellites. And that is one very big advantage because active satellites, those longer wavelengths, they can actually look through clouds. So where Landsat and Sentinel, if you would look at them at forests in Sumatra, and there's a cloudy day, and it is quite often cloudy, you only see clouds, so you don't see the forest. And the nice thing about Sentinel is that it is a SAR satellite, so it actually looks through the clouds. The same is for ALOS 2, by the way. And I wanted to mention the satellites are at the bottom: PlanetScope, Worldview, QuickBird, Spot 6-7. Those are really high spatial resolution satellites. So you can see here their spatial resolution is sometimes even less than a meter, right? 0.3 meters. These are not free satellites. And so if you want to use these images, often you have to pay for it to work with them because these are commercial companies that operate these satellites. They're often used by project developers that need to build a building somewhere or something like that. That's so high resolution imagery. But this imagery also holds a lot of information on forests because you can see individual tree crowns on these images and you can start identifying those and you can get a lot of information from that. So also these satellites are interesting, and some of these companies have deals. For example, our faculty has a deal with PlanetScope. We can get a certain amount of images for free for our students to work on these images. Of course, there's a maximum to it, etc. But we have quite some students who worked on these high resolution satellites because it is very interesting for forestry purposes. What can you do with this high satellite imagery? But one of the things you can do, and this is when you have high satellite imagery, you can segment the image, we call this. So you can do object-based image classification. So you see here the image, and by algorithms, we can detect, okay, where are individual tree crowns and how big are those? Why is it interesting? Well, often there's a relationship between the total area that the tree crown covers, diameter at breast height information from crown information. And this is, of course, a very nice application of high-resolution satellite imagery. So here you see what we call the crown projected area that is estimated from the image, and the DBH, so the diameter at breast height that we can measure on the ground, and there is a positive relationship. And it's not perfect, so there's a little bit of noise in there, but you can actually extract very relevant forestry information when you look at high-resolution satellite images. And of course, you can estimate things like the number of trees, size distribution, perhaps the age of it, etc. We already talked about these different things. Timing. Oh yeah, another thing. What is very nice about satellites is if they pass over multiple times within a year, and you have multiple times that you have an observation, then actually for one pixel, you can make a time series of how the forest or your crop or whatever develops over time. So you can see, for example, if in the wet season, everything gets greener and greener and greener, and then at some point the dry season starts and it gets browner again, so it's going down. These dynamics give you a lot of information about a forest, because if this goes much slower than normal, so if this is the normal trend and it deviates from it, that says that something is wrong. For example, the forest is suffering from a drought, or if it's going very fast, perhaps it was a much wetter year than normal. So you can get information on what is the state of the forest by looking at the time series of different images, but then of course you need to have enough images, so frequently enough an observation. If I would have one observation per year, I could not make a time series within that year to see how the forest is developing or how my crop is developing. There is very nice software that can do that. It's called TimeSat, and it can calculate, for example, how fast it develops, but also what is the total area under this curve. That says something about how good the forest is doing, or how steep it rises, or how long the growing season is. So you can get a lot of information from this time series to tell you something about the state of a forest. What is important to realize, and I already shortly mentioned it, forests are of course often covered by clouds. So these time series, and that's illustrated here, are often very noisy, where there are peaks and dips, etc., as a result of clouds and atmospheric variation. So often you need to do a lot of cleaning. Also, depending on how frequent the satellite passes over, there is a difference in the spatial resolution. Satellites that pass over very often are often very coarse, so you have very big pixels to work with, and that might not always be very ideal. Okay, and then we look into spectral information. I already showed this image. I just zoom out a little bit, or zoom in, I mean. So light that we see with our eyes has different frequencies. And so if we have green light or red light or blue light, they all have a slightly different frequency. So green light is a longer frequency than blue light, but a shorter frequency than red light, right? So that's also what we call about red, green, and blue, or RGB. Right? Those are the three, and there's colors in between there as well. Now, satellites can measure different frequencies, sometimes in very broad bands, so they just measure red, green, and blue. Sometimes they measure the entire spectrum continuously. And this is a lot of interesting information, because different surfaces have different ways of reflecting all those frequencies. So you see here the green light. This is a plant, and a plant reflects a lot of green light. Very little red light, very little blue light, a lot of near infrared, but this is something we cannot see. But water, for example, has a really low reflectance of everything, but it reflects blue the most. Right? So water is really different compared to plants, and soil, again, has yet another profile. So that looks like this brown line here. Now, satellites that can make very accurate measurements of all those different frequencies, and we call them hyperspectral satellites, they normally have more than 100 different bands that they can look at. And this can sometimes give us a lot of information about the chemical composition of plants. For example, how much chlorophyll is in there, or how much tannins are in there, etc. Often we try to link the observations from the ground, for example, how much chlorophyll or how much nitrogen is in the plant, with those very detailed spectral measurements using genetic algorithms or artificial neural networks. So what we call now artificial intelligence methods. Here you see some examples of measurements from different plant species. So every color is a different plant species, and you can see that they are very different when you measure how much light they emit as a result of different wavelengths. So there's really differentiation between plants possible. And if you would put that in an image, then here you see actually the result of, at the top, this is just a red, green, and blue image. So we see a lot of trees, and every tree, is green, of course. But if you look in the spectral light, you see a lot of different colors. So this tree is really different species than this tree, but might be the same species as this tree. So you can use this information to really differentiate between species, but perhaps also say something about how much leaf water content is there, or how thick are those leaves, etc. Okay, how can we use this to our benefits as scientists? I'm trying to wrap up here. Well, actually, you know what I did? I cheated a bit. I asked ChatGPT some time ago, how can we do this? And I got a very nice answer from ChatGPT. I'm not saying use ChatGPT for your science, but sometimes it helps you to formulate something very nice, right? So it says, research plays a crucial role in addressing global problems related to natural resource management. By conducting thorough and innovative research, we can better understand the challenges, we can develop effective solutions, and guide policy and action. And I think these are three very important points that are mentioned, right? So first of all, when you do bachelor science or a master of science, you try to learn to understand the systems you're interested in, right? So if you're a forester, you want to know, how do forests work? How do they operate? How do they respond to changes, for example, to drought or to deforestation, etc.? Then, if you know what the problem is, you can try to think, okay, how I understand this now, what is a good solution? And you can advise the people who make the decisions. And this is very important because often scientists are not decision makers. Scientists inform decision makers. So you have to think, how can I use my science in such a way to use this information in a smart way? So where do we use all this information that we can get from satellites? First of all, scientific understanding, very important. Do we understand how forests work? But secondly, inform sustainable practices. And we just talked about sustainability. This is, how can we ensure that we operate in such a way that also generations after us can still use this system? And so how do we really know that, how do we assess in such a way the information that it is sustainable? And just the example I showed from Brazil, where there was a lot of forest and it's just been chopped down in 30 years' time, that is probably not sustainable, right? We didn't see any regrowth happening. After it was deforested, it stayed deforested. And then you can think, okay, this is not sustainable. So how can we change the system to convert this? Also, to develop conservation strategies. In the example from Brazil, we saw a few pockets that were untouched. Those might be kind of the starting point for any reforestation effort, because those areas have been untouched and still have the pristine original species that used to occur there. So conservation strategies also come from original mapping of what was there, how did it change, and where is still pristine untouched forest, and that we should protect that, but perhaps we can even expand that. Of course, we also need to involve communities. So you can never, as a policymaker or as a scientist advising policymakers, make decisions without involving the people that actually live in an area. So you can't tell them you cannot do this if they were not involved in any of the decision making. So they should also you should somehow develop strategies that people that live there recognize the maps, understand what is happening on the maps, and say, oh, this is happening, and this is the extent of the problem, and that involve them in the decision making. And well, yeah, it is important, although I'm never very happy with this, but also economic analysis is important, right? Ultimately, we need to, as a society, have sufficient resources, including sufficient money, to make practices happening. So conservation is great. I'm always a big supporter of that. Conservation comes with a price, right? And that price has to be paid somehow, or perhaps it can even earn money. We have to make that analysis. That is very important. And lastly, of course, if we say we do something, then we have to check, is it happening, right? So we have to monitor it and say, okay, we see changes happening. Are they changing in the right direction? So remote sensing and GIS play a very important role here. I was focusing very much on land. Of course, similar things happen in the marine areas, but my focus would be on land. Often we look at physical things, right? So we cannot really measure with satellites the social developments, and we can see the result of it, for example, urban expansion. We don't know, for example, how rich or poor people are. We cannot see that. So a lot of the measurements we make are physically based, and they change over time. And we saw that in the example from Brazil. But of course, at the same time, there are humans operating there. And there could be interactions and sometimes even competing claims. So some people want the area to be conserved for nature. Other people want to start developing it for agriculture. And they both have good reasons to do so. So although we cannot measure that, we should take that really into account. So at the last point, here we cannot see everything with satellites. Then we can see a lot, but not everything. So often we have to think, what can we see that makes sense? And what are the right indicators to look at, right? So what is really the information we need to discuss with those people that have different competing claims to come to a conclusion? That also means that we have to understand what is happening on the ground and how that links to satellites. So I'm from a faculty, we use a lot of satellite imagery, drone imagery, etc. But that is never informative without knowing what is happening on the ground. So we say you need eyes in the sky and boots on the ground. So fieldwork is always essential. And you have to think with your smart brains, how can you really use this to make an impact? And I think that was my last slide for today. And we still have a little bit of time left, I think. So I would like to open the floor for any questions or comments from the students or from the fellow teachers.
Oke, silakan kalau ada yang mau bertanya lagi. Student, any question to Prof. Thomas? I think you got so many information and a broader perspective, yeah, about the remote sensing and GIS today. And you also can see that not only Landsat, because Landsat is very famous in Indonesia, but you can see so many satellites, yeah,
Yes.
active or passive satellite, and also you can see how they can work, and you can use the satellite regarding to specific reason, yeah. Please, anyone? Oh, Sarah, we have, yeah, I think we have 12 minutes, yeah, before. Okay, Mido, please. Okay, please, Mido, and then Oisara.
Okay, thank you to Mr. Bejo and Prof. Thomas. Thank you for the opportunity, Prof. So my name is Miduksi Tanggang, and I would like to ask a question. So as we all know, the remote sensing today is not only limited to passive system, but also include active technology such as SER. And as you highlighted earlier, its real strength lies in spatial, temporal, and spectral dimension that enable rapid and precise detection of land cover change. So my question, Prof, with technology, did this advance, why do issues like illegal deforestation, unlicensed mining expansion, or large-scale land conversion still often go unnoticed or underrated? Is the challenge due to technological limitation or rather a lack of willingness to use the data, transparency in policy and decision making? Maybe that's my question. Thank you, Prof.
Okay, thanks. So just for me to get this right, you want to know, now that we have SAR satellites, so it's the active radar satellites, we still have a lot of illegal deforestation happening without noticing it, right?
Yes, yes, Prof.
Yeah. So I mean, the high resolution systems, that is Landsat, a Sentinel, but those are with visible light, right? So they are very difficult to track the deforestation because of the clouds, because a lot of the tropical forests, both in Brazil, but also I think in Kalimantan, for example, or in the Congo, in Africa, they have a lot of clouds. So it's very difficult to monitor this with visible light. And that is indeed where the SAR comes in. But the traditional SAR satellites that I was showing are quite coarse. So they have actually quite a big pixel size. So if you chop down half of the pixel, then in the SAR signal, it's not yet that clear. So we really have to improve these. And there's now this new satellite mission that was launched this year called Biomass. And that one is really going to detect this in much more detail. So we think that in the coming 2 years, we will get much better observation of illegal deforestation. Now, apart from the fact that if we can see it or not with satellites, and we think this will improve in the coming years, there's another issue there, and that is law enforcement. Because you can imagine in a huge forest like in the Amazon basin, if you say as a government, you cannot, when it is 1,000 kilometers away from here, there's a long time for the police to go there. So in the time that the police comes or the law enforcers come, the illegal wood chopping already happened or people are already gone. So apart from being able to see it, actually acting upon it as a government is also very difficult. And the third issue is that some governments actually stimulate this. So what we saw in Brazil was there was a government that was actually very much saying, okay, we don't care about international treaties. We need this money or we need this deforestation. So they just stimulated it, even though it was not according to international agreements. Now they have a new government in Brazil and they're being strict on it again. But sometimes also the government changes and they say, okay, this is actually a good idea. And then it is happening and it is not being taken care of. So I hope that with the new satellite, we have better monitoring. That's only a very small part of the issue because also the law enforcement. And of course, I think perhaps there's even a fourth issue. Apart from the organized deforestation by big companies that have a lot of money, there's also a lot of deforestation happening by poor people that simply have no alternative. And so if you are poor and the only thing you can do is chop down a forest and grow crops, then yeah, it is of course, even if there's international treaties or there's a satellite monitoring you, you still need food for your kids, so you will do it anyhow. So poverty is also a very important driver why this is sometimes happening. And then, yeah, better satellites is not going to help, but better economic development for poor people is actually going to help. So those are, I think, the key reasons why it's still happening.
Okay, thank you very much, Prof.
You're welcome.
Okay. I think Dava first, yeah, Sarah, yeah. Okay, Dava, please.
Thank you, Prof. and Mr. Bejo Slamet for the opportunity. I question researchers struggle to map a forest with optical satellite image because of clouds. She then use LiDAR, which send laser pulses to measure tree height and forest structure even under cloudy condition. My question is, what makes LiDAR particularly effective in estimating forest canopy height compared to passive sensor? Thank you.
So you were referring to LiDAR, right? Now, LiDAR cannot look through clouds. That's not possible. So there is one satellite with LiDAR. It's called GetEye. I actually had it in the slide. I can quickly scroll back to it. Wait a minute. Does this work? So wait, where was my overview with the satellites? Oh, one further. This. Okay. So there's GetEye.
Yeah.
This one is actually a LiDAR satellite. So this is in space, right? It's on the International Space Station, but it cannot look through clouds. But we can also put a LiDAR system on an airplane, and an airplane can fly under the clouds. So if you have a LiDAR system on an airplane and you fly over a forest, then you can measure, of course, even if there's clouds or not, because you're below the clouds. So that actually does work. But then, of course, you need to have the resources and the money. So you need an airplane to fly, etc. So it's quite expensive. So a lot of people resort on the satellite images because it is made freely available, and you've got those websites, so you don't have to do the fieldwork yourself. It's already taken care of by the taxpayers in Europe or America. It's very useful, right? So this is all there. But yeah, if you want to get good LiDAR data, either from the ground with a terrestrial system or from an airplane system, yeah, this is very costly. And then, of course, you also need all the processing software, because what those LiDAR systems collect and how to process that into a cloud-based image that you can process, it also takes quite some hardware to.
Dava, bisa dipahami? Itu kan beberapa satelit ya, kayak GEDI gitu ya. GEDI kan LiDAR juga gitu, tapi dia kan dari apa wahana yang lebih tinggi gitu. Sebenarnya kalau
One question,
Nah.
Prof.
yang mana tuh?
Ada pertanyaan lagi, Pak.
Nggak apa-apa ya Usara ya.
Gak apa-apa, Pak.
Okay, one question, Prof.
How LiDAR as an active remote sensing tool overcome the limit of passive optical imagery in forest monitoring?
I'm not sure if
Thank you.
I fully captured the question.
Bahasa Indonesianya apa tuh, Dava?
Jadi bagaimana LiDAR ini mengantisipasi remote sensing dalam monitoring di hutan gitu, Pak?
Oh, the question is how LiDAR can to fulfill the limitation of passive satellite like Landsat in forest monitoring.
Well, look, it is not always possible to overcome all the limitations of satellite information, right? That is difficult. What we do to some extent is, so we look at, if you look at the Landsat time series, for example, it's not always all the time covered by clouds. So what they can do is they put a lot of different pictures from the same year on top of each other, and you try to find for every pixel a moment that it is not covered by clouds, and you put those together. We call this a composite. So what you can do, if you accept that you do not have every 16 days an image, but for example every month or every 2 months, then you can put all the images on top of each other, and for every pixel you take the best pixel with the least clouds, and then you can make a new picture. And then of course you cannot see variation within the month because you compile it for 2 months, but at least you can see for different years, you can see how things are changing. And this is one way that we try to overcome the issue of cloud cover in tropical forests.
Thank you, Prof.
Okay. Okay. Then Aisara.
Okay, thank you for the opportunity that gave to me, and maybe Professor Thomas Brun already know me. I'm Oisara Terus. And of course, this is the very good for us, for the students, about this knowledge. But my question is talking about, in your opinion, sir, what is the most critical challenge in integrating remote sensing, and especially in artificial intelligence, because artificial intelligence is a hot topic right now, into forestry decision making in this government? That's all, sir. Thank you.
Okay, thanks. Well, I think artificial intelligence, I'm always a little bit careful with that word, because artificial intelligence suggests that the systems we use are intelligent. And actually, they are quite stupid. So I always like to call it machine learning, right?
Yeah.
And machine learning is very useful. Let me be very clear there, right? So I think we can do a lot with it because it can help us automate certain processes. For example, detecting deforestation. So had the process I was explaining to Dafa, that you stack all those images on top of each other, you identify the best pixel for and then you make a new image, and then you identify over different years how has the area been deforested. Machine learning can really help us doing that better. The big issue is, of course, do we trust the outcomes, right? So validation of these machine learning algorithms is really important, because what I already said, I think they're not really intelligent, they're rather stupid, and they need a lot of high quality training data. So a key issue that we need now is, and that relates again to eyes in the sky and boots on the ground, we really need experts like you guys to validate the quality of what this AI is doing, because just blindly accepting what machine learning or artificial intelligence tells you is happening is very dangerous, right? Then it might be wrong and it tells, oh, there's no problem with deforestation, while actually there is, or the other way around, right? So very critical reflection on, okay, what is machine learning telling us? And is this truly happening on the ground? I think that is really key. So I see a lot of opportunity. I think also what is really nice about a lot of machine learning developments is we have the large language models. Everybody knows ChatGPT, right? There's already something called GeoGPT, so you can use geo information with GPT. So this is all happening very fast. The nice thing of it is it helps us as humans to process the data. So you can ask now on those algorithms, how do I write a script? Because a lot of the processing of this data requires you to make a little computer program. This software can help you. You can ask ChatGPT, how do I write the code in Python to process data in this way? And it gives you the code, right? Even if you're not trained as a computer professional. So this is perfect for foresters. Then you use the code, you run it, you get some result, but then it's still you who has to check this, right? So I think what is key here is having a very critical attitude. Don't accept everything that artificial intelligence tells us, right? Use your own intelligence, but make use of it because it can really make your life much easier.
Thank you, sir, for your advice.
Thank you for your questions. I think it's a
yeah.
nice and interesting question. Yes.
Yeah, I think AI is like sometimes become worse. And,
Yes, absolutely. Yeah.
yeah, Prof. Thomas, I have experience. I've used Sentinel-1 for land cover classification and mountainous area because we have problem with a cloud. Almost
Yes.
every Landsat scene that we got is there is so many cloud, but
Yes.
using Sentinel-1 we have low accuracy. I think because the land cover in the field is very very complexity. We
Yes.
are not can have a good training area to differentiate one to another. And I think although we have opportunities to get the free cover from cloud, but actually sometimes we have also have a low accuracy in land cover
Yeah, I agree.
classification.
So especially for agriculture. So I think distinguishing between forest and non-forest, that's okay with Sentinel-1. But if it is non-forest, and then you say what kind of crop is it? Is it rice or is it something else? That's very difficult. So then actually you still want to have visible bands from Sentinel-2. And yeah, then you need no cloud. So ideally you have a combination of the two. But yeah, that's not always possible.
Yeah, I think math classes and very very low accuracy. So I think the class must be make a simple. So your advice is also good for a student if there is a problem with cloud. We can use a composite image, and we can make some period that we know that in the field there's no changes. So I think we can use composite image, satellite imagery.
Yes.
Okay, Prof. Thomas, because this is, I think, in your.
It's time to go. I also have to go to another meeting. So.
Okay. So
Yes.
see you. Yeah, I think tomorrow.
Yes, tomorrow I will be there again. Yes.
Okay. This is Punita, and thank you very much.
Yes, I see Anita's also there. Hi, Anita. Good to see you.
Sorry for coming so late.
No problem.
So
You
see you
warned me. It's
tomorrow,
okay.
Prof. Thomas, and I hope that the student can join tomorrow and make a more enthusiasm activity,
Yes.
and diskusi. So
Thanks
thank you
a
so
lot
much.
for the hospitality. It was great seeing old friends again, and also thank you all the other students for meeting and for the very nice questions and joining when I asked a question that you gave answers. That was very much appreciated. So thank you very much, and I look forward to tomorrow. Bye bye.
Okay, bye bye.
Maybe take a picture, Thomas.
Oh yes,
Yes, forgot to take a picture.
Maybe stop the sharing, please.
yes, I will stop the share.
Okay.
Thank you so
Yes.
much, Prof. Thomas, and everyone. So I believe you are all enjoying the lecture from Prof. Thomas because so many interesting in the presentation. I believe so. So
It's a really big group,
yeah,
more
it's a
than you
big
said.
group. Actually,
Yeah.
it's a fit in, but it's very nice. Also, we have 3 postgraduate students here still attending the class. It's so nice. Thank you, everybody. Ulfa, thank you. Maybe Ulfa could lead, or Oisara could lead take a picture for us.
Yeah, I have take the picture
Okay.
to slide. Okay, I will share.
Okay.
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 Okay. All the slide.
Yeah,
Yeah.
already.
Okay.
Okay, already.
Okay. Okay. How
Thank you.
what time is it, Prof. Thomas, in the Netherlands? I think
2 o'clock.
2 o'clock. So you missed the lunch already, or you have lunch?
No, I already had lunch.
Oh, oh, so
Okay.
sorry. So
Um,
okay. So have a nice lunch. Okay.
Okay, bye-bye.
You.
Thank you.
Yeah. Okay.
Thank
Bye-bye.
you.